Welcome to another Comptia video. As always, thank you for watching the video. Give me a thumbs up if you did like the video, but let's go ahead and get started. Don't want to waste any more time than I have to. So this is going to be module 2.2, guys. All right, so before I get started with this networking section, I do want to go over really quick what is a LAN and what is a WAN, because you will hear it a lot in different Comptia exams. You will hear it a lot in, like CCNA if you ever go that route, networking. But it's very important that you know differences between a LAN and a WAN. So a LAN is a local area network. That's what it stands for, local area network. So what is a local area network? So a local area network is a collection of devices connected in one local area. We all have a LAN. If you have an internet set up at home, that is your LAN. Everything behind your router essentially is your LAN. So this consists of all your devices. It could be computers, TVs, video game consoles. If you have a fridge that needs access online, your fridge would be considered part of your LAN. And in the next slide, I will show an example of a LAN and a WAN. To finish off, what is a LAN? So all these devices share communication line. It's just your network. So once you go outside of your own network, you go into WAN territory. So we'll go over this in the next slide, but really quick, I just want to quickly go over what a WAN is. A WAN is a wide area network. So what is a wide area network? A wide area network is a large network. It's not tied to a single location. It extends over a large geographic area. So if I have my house here, and let's say I want to move to somewhere else in California. I live in California, so I want to move somewhere else in California. So I'll move there to another house, and then I connect my two LANs together. Essentially, that would be considered a WAN. When we connect to the internet, that could be considered a WAN, because the internet is nothing but a bunch of routers, a bunch of servers, switches, all this hardware. That's what the internet is. Essentially, it's all these devices connecting to each other. So a WAN can be considered the internet. It can expand over the entire internet. And also keep in mind that a WAN can also be as small as a company with a few different locations, and it's all connected through leased telecommunication circuits. So let's go ahead and go to this next slide where I have an example of two LANs. So this is a router here. Here's a router. And this is all of your devices that are connected to your network. You have a cell phone here. You have a cell phone. You have your computers, your laptops, TV. You have your video game consoles here. Maybe another TV. It's all connected because you have to have internet access on all of them. You want to download the latest games. You got to have internet access on your consoles. You want to watch Netflix and chill on your TV, you need to have internet. If you want to, go do stuff online on the computer, you need internet, obviously. Same with your phone. So everything here connected to each other is your LAN. All of these devices can talk to each other internally. It does not have to go outside. When you go outside, here is outside. As soon as you leave the gateway, as soon as you leave your own network, you are outside. You could be going to the internet, or, like I said, once you leave, you could leave your own LAN and go to another LAN. So this is what a LAN would look like, just here, or maybe you have this. This is a LAN. So what is a WAN in this case? Let's go ahead and delete all this just so we don't confuse anybody here. But what is a LAN? What is a WAN in this case? So let's say, as you can see, these two LANs are connected. And let's say this is in, this is in the US, and this could be in the UK, for example. So this would be considered a WAN. This could also be in the US, It It could also be in the same city, same states. As long as these two are connecting to each other and they're not in the same building. Keep in mind, there is something called a MAN, Metropolitan Area Network, which is smaller than a WAN. But, it depends on the person that's building the networks and their definition. But essentially, if you have two different LANs connected to each other over a certain distance, it is considered a wide area network. All these devices can talk to each other. This device should be able to talk to this device. This device can talk to this device. It could talk to this router. That is what a WAN is. It's all connected. So let's go ahead and talk about routers. So a router is used to connect LANs. As I showed in this picture here, these two LANs are connected. It's connected through the router. Through the routers. There's two routers here. So these two routers are connected to each other. So a router is used to go outside of your LAN, outside of your own network. A router makes forwarding decisions based on IP addresses. So essentially, a router will have a routing table. I'm not going to go far deep into this at all. Just know it has a routing table. And that's how it makes forwarding decisions. It sees like the IP address that it has to connect to or the subnets. We will talk about subnets soon. But it sees that and then it says, okay, I have this IP address or I have this subnet. Where do I send it? So that information will be in a routing table, and that's how it knows where to forward traffic. So here's two examples of a router. Here is a Netgear router. This is most likely a small office, home office router. We just connect to it and it works. This one right here is a Juniper router. Juniper routers, obviously, these are usually what companies will buy. You can configure all kinds of stuff on them. They're not plug and play. You have to configure it. And they have a lot of ports. They have a lot of functionality. So huge differences. We're most likely familiar with this. We have internet at home. You most likely have one of these routers. All right, so we're going to talk about hubs. So what the heck is a hub? A hub is an older type of device, guys. It is not really used much anymore. It's still out there, but we've moved to switches. Hubs don't do as good of a job as a switch. And this goes to my next point, is a hub is known as a dumb switch. So there is no intelligence to how a hub forwards information. It's also known as a multi-port repeater for the same reason. And what I mean by that, what does a hub do that makes it dumb? So let's say we have a hub here in the middle. As you can see, this is a screenshot of a hub, and I also included this, it's kind of like a hub is sending an email. So let's say you have a hub in the middle and you have 4 computers that are connected to this hub. So this is what a hub is going to do. Essentially, data is going to come into the hub. The hub is going to get the data, but the hub does not know who to send it to. So all it's going to do is send it out to everybody on the network. The hub is going to send it out to this computer. It's going to send it out to this computer, and this computer, because the hub has no intelligence. So that's why it's called a multi-port repeater. It's essentially just repeating to all the ports. So in this case, they are very inefficient. They're essentially spamming the network. So every one of these devices will get the information, but the device that needs the information will accept it. This computer will take it, but all the other computers will say, this isn't mine. It's just gonna drop the data. Hubs operate a half duplex, so only one device can communicate at a time. And like I said, hubs are not the best network device because they only provide a way of sending data, but they don't have an efficient way of sending data. And in this case, I included like a little email. This is from a hub. It's going to everyone. and it received data from Google. It's just saying to everybody on the network, hello, I don't know who this is for, but I'm sending this out to everybody. Attached is the data from Google. Only the proper receiver will be able to open it. Everyone else, just please discard the information. Thanks. So that's essentially what hubs do. Imagine if emails work that way. You get emails for everything. So let's go to switches. Switches have replaced hubs. Switches forward information to the port that is connected to the destined device. So how does it do this? Well, switches have what is known as a MAC address table. So let me show you how switches forward data on the network. So in the middle, we have a switch. We have 4 computers. Computer 1, 2, 3, 4. So essentially, let's just say this computer here wants to send data up here. So on a very basic level, this is what's going to happen. The computer will send data to the switch. It has to go through the switch. The switch will see that this computer, which is connected on this port, let's just say this is port number 1. Since it's getting the data from port number 1, the switch will then remember, okay, this computer MAC address, 1111, something like that. Whatever the MAC address is, it'll save it, and then it'll say it has this IP address, 10.1.1.1, and it's connected to port number 1. It'll remember. However, this is where the switch does not, in this particular case, the switch does not know the IP address of him yet. So essentially, the switch will, in this case, contact everybody. It needs to contact everybody to say, hey, who is IP address 10.2.2.2? The switch is going to send that to everybody at first. Of course, these computers will ignore it. They're not 10.2.2.2. But this computer will say, hey, that's me. Here's my MAC address, by the way. And, it sees it's connected to port 2. So the switch will keep that in its table. So the next time data destined for this computer right here, the next time data is destined for this, it will not have to send data to everybody asking, who is this? It's going to remember it's connected to port 2. Just going to send it out port 2. Hopefully not too confusing. If you do have any questions, though, feel free to leave a comment. I'll do my best to answer. And last but not least, there are 2 types of switches. So there's managed switches and unmanaged switches. So let's go over managed switches really quick. Not too much we have to talk about, but usually these are used in enterprise networks. Unless you have a lab or something like that, or you just want one for some reason, you're not going to be having this big old thing at home, Managed switches can be configured with advanced features. Of course, we'll discuss that another time. These can be remotely managed using a CLI and sometimes a graphics user interface. That's pretty much it for managed switches. Just remember, using enterprise networks, you can configure them with advanced features to do crazy things. Unmanaged switches, on the other hand, sounds like it is. It is unmanaged, usually plug and play. They cannot be configured remotely, and they provide basic switching services, full duplex, smart forwarding, of course. Managed switches are usually pretty small. I actually have one of these at home. With these, you just plug it into your router, and you can plug your computers into these ports, any of your devices into these ports. They would work like this. With managed switches, remember, you plug it into the port. The port is not going to know what the heck is going on. The port needs to be configured. The switch needs to be configured. So just keep that in mind for the exam. You might be asked about that. All right, let's talk about access points. So whatever you do, don't confuse an access point with a router. We usually have routers at home that is a combination of a router, an access point, and a switch. Access points by themselves, things we use at companies and different businesses, they don't provide routing functions or anything like that. All they do is they're a bridge So all they do is they extend the physical network. So you have the physical network, blah, 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 wires, all this stuff, whatever. But you'll have, wire here connected to an access point on the ceiling. All that's going to do is just going to bridge the connection and then broadcast a wireless signal, allow computers to connect wirelessly. So it's just a bridge to allow devices to connect wirelessly, essentially to the wired network. These devices create a wireless LAN, wireless local area network. And similar to a switch, they make forwarding decisions based on MAC addresses. APs have built-in antennas, transmitters, and adapters. Like I said, they're known as a bridge, and do not confuse these with routers. Very important that we don't confuse APs with routers, because of course the routers we have at home also act as an access point. These access points, I always like to think that, we have devices that do one thing. Just like, you want to master IT, you want to master not all of IT, because IT is so broad. You want to master one thing in IT. That way you'll be the master of it. You'll be super good, whether it be networking, systems, so and so. Kind of similar with these devices. If you have a device that only does one job, it's going to do that one job very well. If you have a device that's going to do all kinds of stuff, not all resources will be dedicated to that one job. So that's why there's so many different types of devices. Just in case you were wondering, just in case you happen, to give a damn about that, but just thought I'd mention it. Anyways, let's talk about patch panels. So patch panels can be confusing if you haven't seen them. These are usually located in the network closets. You will learn about MDFs and IDFs, main distribution frames, and intermediate distribution frames. Just know the MDF, main distribution frame, could be like the main server room. The IDF, intermediate distribution frame, could be like, it could be other server rooms, but it's not the main one. It could also just be one spot. You can have a box. You get somebody to build a box on the wall. Maybe you'll install a few switches on the wall or something like that. You'll cover it with a box, and it'll connect to, the MDF, something like that. However you have it set up, but don't worry about the MDFs versus IDFs. We're just going to keep things simple here. And we're just going to say, we have one closet because we're in a small business, just one closet, okay? And we have in this one closet a switch rack and other stuff, but we're just going to focus on the switch rack and all the networking devices, all that good stuff. This is all we're focused on. We're not focusing on anything else. Inside this closet, we have, switches. Let me just draw 2 switches. I'm just going to draw 2. I don't feel like drawing too much. So we have some switches, and we'll have patch panels here. Here are the patch panels. I'll make it kind of like a weird shape. Obviously, it's not going to be like this in the real world. This is a patch panel. It's square, but just wanted to make a difference here in my drawing. But let's escape the closet for a second. Let's go to a person's desk. Somebody sits here. Let's call him Frank. He's happy at work. Well, alien Frank. Let me make that a smile. Okay, he's not very happy at work. It's okay, Frank. Day's almost over. But, he's sitting down on his chair. So he's using the computer. His computer is here. Here's his computer. And obviously his computer needs to connect to the connection, RJ45, the wired connection we usually plug into our computers and to the switches and all that stuff. Here's an RJ45 connection, by the way. It's the cable. We'll learn about that, don't worry. But anyway, so he has his computer here. And, it's connected to the wall. Here's the wall. Here's the connection on the actual wall. So it's plugged in to here. Even us as IT specialists, our first step will be this part. There's internet troubles, connection troubles. We'll check the wall here. We'll check the connection from the computer. We'll troubleshoot this first. Now here's where things usually get confused by a lot of people. We don't care about this. So there are wires in the walls, above the ceilings, places we can't see. So essentially, there's going to be a connection back here. It's just going to be another wire, and it's just carrying the connection even farther. So this connection right here, we're all good with this, but behind the connection on the wall, we have another cable going who knows where. It could be in the ceiling, wall, let's just say ceiling. So it's going above the ceiling, yada yada, and it's making its way to this closet. That's where it goes. We don't even see this cable. All we see is this wire right here. We don't see any of this unless we're really trying to look. So this will connect to the patch panel. So now let's take our focus and put it on the patch panel here. Let's focus here. So here's that connection that I was talking about. This is going to this part's going to the ceiling. We don't really care. It's super long cable. This is going somewhere else. But we can see this in the patch panel. We can see this connection, but we don't want to touch it, because if we start touching things here, we can mess things up. Because usually at the desk, let's just say this desk, it's labeled number 1. It'll also have the closet name, or it should. So it has the closet name and has number 1 on it. So that's how we know where to look for this cable if there's any connection trouble that we can't solve here. So we'll go to the closet that we see is connected to, and then we'll look at number 1 and we'll be like, okay, this is going to be this desk here where Frank is sitting. It's labeled. It's there for organization purposes. That's the whole point of a patch panel, guys. It's there for organizational purposes. That way, there's this Ethernet connection now. There's this connection. Now let's move our way here, where I have this little circle here. So let's just pretend this is number 1 still. I know it says 11, but who cares about that number? This is still 1, same patch panel, same everything. This is now connecting to the switch. So we can trace this. So let's bring this all together. Let's start from Bob's desk. You see it says number 1. It should say the closet is located. So it makes it much easier to find. So we see the closet, we see number 1. We go there. We see this, we go to that closet, we see number 1 here, and now we can trace it to the port on the switch. So in this case, we can see 1 is connected to port number 1. So we could maybe tell network engineers, or if you're a network engineer yourself, or you manage the network, you can now know which port is connected to by tracing it. You can switch out the cable if you have to. You can, configure the port, do anything you want. But what I'm getting at is a patch panel is there for organizational purposes. Imagine if we didn't have this system. It would be a nightmare to find the correct port. We'll have to trace this long cable back. Imagine if it didn't even go through the ceiling. It'll be on the floor. Then you'll have people tripping. It's a safety hazard, obviously, and it's super ugly, messy. We don't want that. So that is why we have patch panels. It's there for organizational purposes. So like I say here, it centralizes and connects cables running through the walls from different hosts. So here's the host, this computer. It's running here through the wall, through the ceiling, and it's all centralized to this one patch panel. It's centralized. So keep in mind that connecting to the patch panel does nothing in itself. It's just there to be organized. If there's no cables on this end, if there's no cables here, it's not going to matter, because, we're just connecting to the patch panel, but there's no connection to the switch, which gives it the actual connection. So the switch does all the work. Patch panel, like I said again, just to organize. Let's go ahead and move on to firewalls. So I always like to say the firewall is the network bodyguard. So what does the network bodyguard do? What does the firewall do? It allows or denies traffic in the network based on IP address and port numbers. There are next generation firewalls, which we'll talk about in a second, but let's just focus on this for now. So I have a screenshot here of a firewall GUI, and I'm monitoring some traffic, and you can see source IP and destination IP. Here you can see the traffic is allowed, and then here you can see the port. The port is 161. I actually blocked out the 1, but so essentially we could say, source IP, destination IP, we can say, from this IP address to this IP address, we want to deny traffic. So this will be deny instead. Traffic will not be allowed. We can do that. We could even block out the port. We can say from this to this, only block out port number 161. Then this will be denied. So older firewalls, usually firewalls just block based on IP addresses and port numbers. You can have fun with that. Next generation firewalls, however, they can allow and deny based on application. So you can see the application section here. You can see SNMP base. Remember we talked about ports? Remember SNMP? Remember that? So you can see this is SNMP traffic, but we can block SNMP traffic. We don't have to specify, port number in this case. We could say, from the IP to this IP, block SNMP traffic. Some firewalls can encrypt traffic between sites. This is site-to-site VPN connection. So you have two sites here. They're essentially connected to each other over the internet. They're going to and from each other through a public space, through the internet. But this traffic will all be encrypted. Nobody else can see. Nobody else can connect. Can't exploit that kind of stuff. So very cool. And some firewalls can also be used as a proxy. So you have a firewall here, you have the internet here, and you have a user with his computer. I know this is a terrible person, but he's using his computer. So traffic will go to this firewall. It'll act as a proxy. It'll inspect whatever the user is sending, and it'll be like, okay, this is okay. It'll send it to the internet. It'll come back. The firewall will look and see what's going on, make sure everything is legit. If it looks legit, it'll then send it back to the user. So that's what I mean by proxy. It just sits in the middle and it acts as an intermediary. All right, let's go over power over Ethernet. So I didn't know this was super important in Comptia until I looked over the objectives, but it was going over it pretty good. So let's go ahead and talk about power over Ethernet. So what is that? It is what it sounds like. Power supplied over an Ethernet connection. So very useful because sometimes a power outlet will be far away from the device that we need to power, and that needs, internet access. So we don't want to have for example, this IP camera here. Let's say the power outlet was far away. We don't want to have a big old power cable, it might have a brick too. That'll be dangling from the ceiling, wherever you want to put it. And sometimes you might want to hide the IP camera, be kind of conspicuous. PoE, using a PoE switch, is called an end span. Remember this. If you use PoE, power over Ethernet, directly from a switch, it's called an end span. And PoE is used by wireless APs, IP cameras, and even phones. Just to go over PoE using the PoE switch, we can see in this diagram here that, we have, let's just focus on this IP camera here. We can see we have the IP camera and it's directly connected to this port. And it's just gonna have power. It's that simple. No need for power cables. Just connect with an Ethernet cable. We can put this on the ceiling, connect one cable through the ceiling, boom, we're done. Don't need to worry about anything else. So let's talk about PoE injector. So if the switch does not provide PoE functionality, a separate device called a power injector will need to be purchased. So this adds power to the Ethernet cable. And this is called a mid-span. Remember this for the exam. If you use a PoE injector, it is known as a mid-span. So remember end span for switches and remember mid-span for PoE injectors. So essentially how it works is we have this network switch here, which is connected with the RJ45 port to this power injector. And the power injector is connected to power. So essentially power goes to this power injector. Then when you connect Ethernet, it just supplies the power from there. Pretty simple, nothing too crazy. Just make sure you remember end span and in this case mid span. All right, so let's just talk about PoE switch really quick. So like I said, this is when PoE comes built into the switch. In enterprise grade switches, the ports can be configured to provide power to the connected devices. And usually the switch will indicate which ports support PoE. In this case, you can see ports 1 through 4 support PoE. And port 5 does not. So you see port 1 through 4, it says the watts, port max. Port number 5 says nothing. And here's a chart of the PoE standards. You might have to memorize these standards for the exam. Not really much to explain here. Just try to memorize this chart because it might be in the exam. All right, let's talk about a cable modem. So what is a cable modem? We should be familiar with a cable modem if we have internet at home. So modem is actually short for modulator, MO, demodulator, DEM. And all this does is it connects to the internet using copper cables or telephone lines, essentially over a broadband connection. What this does is it modulates the digital signals generated by a computer into analog signals that can travel over a broadband connection. The receiving modem converts the signal back into a digital connection. So, this will go to wherever it goes. When it comes back, it'll then demodulate into a signal the computer can understand. This uses the same cable that you would use for your television. So we use the coax cable F connector for our TVs. We can also use this for internet. This uses DOCSIS. You might have to memorize that for the exam. That is just the standard for sending data over this cable network. And cable modem supports speeds up to 1 gig per second. Not too much to talk about modems. Just know what it does. Modulates, demodulates the signals. Is used for broadband connection. And it uses DOCSIS. Maybe remember the speed. Fiber is a lot better. We'll talk a little bit about fiber, but not too much. Let's go ahead and talk about DSL. DSL uses existing telephone lines with a DSL modem. Same lines used for telephones. And this is where it kind of gets confusing. So multiple types of DSL exists. Asymmetric DSL, which is the most commonly used DSL. There's also symmetric DSL. I'm not sure if the test goes over very high bitrate and high bit rates, but I did include it. But for now, we're just going to talk about asymmetric DSL for now because it is the most commonly used DSL. It's called asymmetric DSL because it provides a higher download speed than upload speed. Symmetric DSL, on the other hand, provides symmetric bandwidth speeds. The upload speed and download speed will be the same. The drawback is you cannot use the phone at the same time. And here's the ADSL speeds, guys. 52 megabits per second downstream, 16 megabit per second upstream. And the reason why I combined these is because in this case, asymmetric DSL and very high bit rate similar. And in this case, symmetric DSL and high bit rate is similar. All right, let's talk about optical network terminals. So this is used for fiber. Optical network terminals work the same way in which a cable modem provides internet access. The only difference is that these terminals provide internet access from a fiber network. So what it does is it converts fiber signals into digital and then vice versa. So you have your computer produces digital, it comes here, it converts it into fiber, which is lights, which is super cool, but we'll learn about fiber. And then from the ISP, it'll be fiber in here, converts it to digital, go to your computer. These are known as demarcation points. So all a demarc point is, guys, is it's just a point between your network and the ISP network. So this is the demarc point, because here's the ISP network. The ISP network is from this fiber line right here. Goes to the ISP. This has a lot of cables connected to it, but most likely will be from this RJ45 connection into your network. So that is why it's called a demarc point. It's just a point that sits right between your network and the ISP network. All right, let's quickly talk about network interface cards, NICs. Not too much to talk about here, but all a NIC is an expansion card that is installed in devices that need access to the network. So as you can see here, this is the PCIe slot you plug into your computer. We will go over that. I don't believe we have yet, but this plugs into your computer's motherboard, and then you just plug into the RJ45. That's pretty much it. Most devices do have built-in NICs, so usually we don't have to install one. All right, so this is the last thing we have to talk about. So we have to talk about software-defined networking. I didn't learn about this really until CCNA, so it's kind of crazy that Comptia A+ is like talking about this. But anyways, let's just go ahead and talk about it. So actually, before we do talk about it, we need to learn about the three planes in which form a network architecture. The first plane, you have the control plane. I'm going to try to draw a brain. I don't know, guys. I'm not a good drawer, but the control plane is pretty much the brain of the network. It controls how data packets are forwarded. So for example, this plane may create a routing table, MAC address table like we talked about, and so on. So think of the control plane as the brain. I don't know why I keep trying to draw, but we're just gonna try to draw somebody's arm. We have the data plane. So the data plane is what actually does the work. The data plane is also called the forwarding plane. It carries the user's traffic, processes networking frames, etc. So the data plane actually does the work. Remember, control plane is the brain, has the MAC address table, forwarding table, routing table, all that stuff. It tells the data plane what to do. Data plane doesn't have to think about any of that. The data plane says, okay, this takes it. And last but not least is the management plane. I don't know what to draw for this. Really much I don't have to, because it's super simple. It just allows management and configuration of the device. It also does perform monitoring, but a good example of the management plane would be, you SSH into a switch or a router, or, you might log into a device from the web browser to configure it, do all kinds of stuff. But that's all the management plane is for. Just lets you log into it and do stuff to it, configure it. So now that we got that out the way, now we can talk about actually what the heck is software-defined networking. So in a traditional network, the control and data plane is located in the firmware of the network device. So let's just say we have these switches. I'm just gonna draw 4 switches here. Each switch, this is the firmware chip, but they all have their own control data plane. They have their own brain. So essentially, they all make decisions individually. So SDN, software-defined networking, assumes control. Mass Effect 2 reference, by the way, but it assumes control of the control plane. So it says, hey, I'm the brain. Essentially, the control plane is put into software. So this is cool because it allows more programmatic access. Somebody could be over here, typing on their computer. They're programming a script with Python. It goes to here. Let's just say this is like the server or whatever that tells these devices what to do. So I'm just gonna draw this. This is taking control of the brain. So this is the brain now. This is the brain. So essentially, he'll write a Python script. It'll go here. And then from there, you know, he can do whatever. He can extract a bunch of information from these devices. He can configure this to essentially just tell this what to do. All of these will do whatever he says. So no longer does each individual device have to have a routing table, forwarding table, all that stuff. Much more efficient because now you have one device that knows everything and it just tells each switch what to do. Very useful, very efficient in networking because you can scale hardcore in this case. Very high scalability when you use software-defined networking. That is a huge plus to this. Also, you can cut costs and you have much more efficient network management. Again, because you only have to tell this what to do. You don't have to tell each individual switch what to do. That is the last slide. I know this has been a lot of information I just dumped on everybody. Hopefully not too complicated. Again, if you have any questions, feel free to leave any comments. But anyways, thank you for watching the video and I'll see you in the next one.